Agora eu gostaria de apresentar para vocês a professora Camilla Gilmore, da Universidade de Loughborough, que é uma das principais pesquisadoras na área de cognição numérica na atualidade. Ela é, inclusive, autora de um livro muito bacana, Introduction to Mathematical Cognition, que saiu em 2018, que eu recomendo, né? Uma boa porta de entrada na cognição numérica. A professora Camilla Gilmore trabalha num centro pioneiro de educação matemática na Universidade de Loughborough, na Inglaterra. É uma das primeiras professoras do mundo que tem uma cátedra específica nessa área de cognição matemática. A palestra dela vai ser sobre as habilidades aritméticas de crianças prematuras, que é um assunto extremamente interessante, no meu ponto de vista, com implicações importantes, tanto do ponto de vista educacional quanto do ponto de vista clínico. Aproveite.
Hello, everybody. It's very nice to be involved in this workshop this week. My name is Camilla Gilmore, and I work in the Centre for Mathematical Cognition at Loughborough University in the UK. And I'm going to be talking about the mathematical learning difficulties that might be shown by children who've been born preterm. So I'll start off by explaining why I think we should be concerned with preterm birth and why this might have an impact on children's future development and education. And I'll look at some of the long-term effects on cognitive development and the impact that these have on learning and education. And then I'll focus most of the talk about the nature of the mathematical difficulties that are associated with preterm birth, and then finish off by looking at how we can support children who are born preterm in the classroom. And I'll point you to some extra resources that you might find useful for this. So first of all, you might be wondering, why should we be concerned with preterm birth as educational professionals? And we know that, sadly, there's 15 million babies are born preterm each year, and that prematurity is the single biggest cause of newborn deaths. However, fortunately, thanks to improvements in medical care, severe physical disabilities and illnesses are now less common. However, difficulties with cognitive skills are much more common than physical disabilities. And unsurprisingly, this then has an impact on children's learning and education. So the vast majority of children who are born preterm attend mainstream schools. And we know that preterm birth rates are rising. So the numbers of children who are born preterm and will be in the classroom will increase in the coming years. So it's likely that almost all teachers will be responsible for supporting children who are born preterm. For example, we know that in the UK, on average, 2 children in an average-sized primary classroom will have been born preterm. So it's very likely that teachers are caring and supporting children who are born preterm all the time. Research has shown that preterm children are at risk for some complex cognitive and educational difficulties. And so understanding what these difficulties are and how to support children in the classroom is crucial so that preterm children can achieve their potential. So first of all, just a couple of definitions for you. So what is preterm birth? Any pregnancy that lasts 37 weeks or more is considered to be a full-term pregnancy. So babies born before 37 weeks are considered to be preterm. Within this, babies who are born less than 32 weeks are considered very preterm, and babies born less than 28 weeks of pregnancy are considered to be extremely preterm. And there's now a lot of evidence to show that there are increased risks of difficulties for children the earlier they are born. And it's really important at this point to stress that this is a risk of difficulties. So not all preterm born children will have cognitive and educational difficulties, but the risk of this is higher than for children who are born preterm. and the risk increases the earlier in pregnancy that a child is born. So some of the key findings now that's coming out of quite a large body of research has shown that preterm birth can affect multiple areas of development. And this includes both cognitive skills and social and emotional skills. I'm going to be focusing in this talk about impact on cognitive skills. So most research has focused on very preterm children, so those born before 32 weeks of pregnancy. But effects of early birth can be seen for children who are just a few weeks early, so the late or moderately preterm children. However, as I said, the earlier that a baby is born, the greater the risk is that they may develop long-term problems. And it's also important to note that the problems can be seen in infancy, but also they can persist throughout life. So it isn't the case that preterm born children will just catch up after a few years. We can still see impacts of prematurity throughout adolescence and into adulthood. So there are now consistent findings from many studies throughout the world that has shown that there are certain cognitive skills that preterm children are at risk of having difficulties with, and they may struggle with compared to children who are born full term. And this has shown that simultaneous information processing is more likely to be impacted than sequential information processing. And also that non-verbal IQ tends to be more impacted than verbal IQ. Deficits have been found in a wide range of cognitive skills, including working memory, visuospatial skills, attention, processing speed, and executive function. And these difficulties have really been found to have impacts then on learning difficulties and educational achievement. But preterm children have also been found to have difficulties with language, fine motor coordination, and sensory processing more generally. As I mentioned before, the level of the impact of prematurity increases the earlier that babies are born. So this graph shows data from two different studies that look at the impact of preterm birth on a general measure of cognitive skills. And it's shown that it shows the mean score on the cognitive skills battery for children who are born at different lengths of pregnancy from 22 weeks up to 42 weeks. And the graph shows that the earlier that children are born, the risk of difficulties increases and the severity of the difficulties increases. So for children, the biggest impacts are seen for children who are born the earliest and in the extremely preterm region. Now, as you'd expect, this sort of level of cognitive difficulties has been found to have an impact on children's education and their learning. This graph shows data from a large study of preterm born children in Scotland. And the graph shows the percent of children who have been identified to have special educational needs. So these are children who've been identified by their school as having difficulties and are being given additional support. And the graph shows the percent of children with these special educational needs according to different weeks of gestation, from 24 weeks up to 40 weeks. And as you can see, the rate of special educational needs increases the earlier that children are born, and are particularly the highest for children who are born before 26 weeks of pregnancy. But it's really important to remember that only a very small proportion of babies are born at these very early weeks of pregnancy. Whereas there are many more babies who are born late or moderately preterm, so between beyond 32 weeks, 33 weeks of pregnancy. And so although the chances of having special educational needs at this time of birth is lower, this is the group of children that you're more likely to encounter in the classroom. So here the risks are lower, but there are many more babies born at this sort of time. So we know that as a group, children who are born preterm have lower attainment across all subjects, but studies have shown that they are most likely to have difficulties with mathematics, and that this can be seen throughout both primary and secondary education. So this graph shows children's achievement across different subject areas for children who are aged 5 years old in the UK, and that means they've finished 1 year of formal education. The graph shows the percent of children who've been determined by their teachers to have reached a good level of achievement. And this is shown both overall and for the different areas of the early years curriculum. The blue bars are showing children who've reached this good level of achievement for children who are born very preterm, and the orange bars are showing the levels of children who've reached the good level of achievement for children who are born full term. And as you can see, that for both overall areas and for each of the individual areas of learning, there is a difference between the blue bar and the orange bar. So the very preterm children are doing less well across all the different areas of the curriculum. But the area where the biggest difference between the bars is for mathematics. And in fact, in this study, they found that 70% of the children who were born at term had reached a good level of achievement, but only 46% of the children who were born very preterm had achieved this same level. So for some reason, mathematics is an area that seems to be particularly impacted in preterm born children. So that previous graph showed data when children who were just at the beginning of their education journey, so the first year of primary school. But we know that these difficulties persist, that it's not a case that just after a year or two, children, preterm born children, are able to catch up. So we also see effects for children at the end of primary school. So this figure shows data from a study that looked at children who were born extremely preterm and were assessed when they were 11 years old. And the figure shows, rather than performance on an assessment, this is teacher ratings. And the graph shows teacher ratings for the extremely preterm born children in different subject areas and in comparison to term born peers. So the further away the line and the points are from the 0 line indicates a bigger difference in comparison to term born peers. And again, that we can see that it's mathematics where the data points are furthest from the 0 line. So the biggest difficulties that children were having, preterm children were having, was in mathematics. So this is for 11-year-olds, and clearly the difficulties that are found in the early years of primary school are not going away, and if anything, they are potentially increasing as children go through the first years of education. So why is it that maths is particularly affected, and what might cause these specific difficulties with mathematics? I think to answer this, it's helpful to consider what contributes to success in mathematics. And research in mathematical cognition has identified quite a broad set of both domain-specific and domain-general factors which contribute to overall mathematics achievement. So in terms of domain-specific skills, so these are skills which have been found to be important for mathematics achievement and that are specific to mathematics. So this includes things like the nature of individuals' mental representations of numbers and quantity, also their procedural skills, so how well they're able to carry out procedures and process information and carry out different strategies. Conceptual understanding is also very important. So this is children's understanding of the principles that underlie the strategies that they're using. And finally, number fact knowledge has also been associated with mathematics achievement. So these are all skills, what we call domain-specific skills, that are only specifically associated with mathematics achievement. But there's also a set of domain-general skills that have been found to be associated with maths achievement. And these are skills that are important for maths, but they're also important for learning in a whole range of different subjects. So this includes working memory, executive function skills, how we control our thoughts and actions, verbal ability, and visuospatial skills. So one of the reasons why maths is such a difficult subject to learn is that it draws on all these different domain-specific and domain-general skills. And when we think about trying to understand the difficulties that preterm children have, it's possible that any of these different areas, these different specific skills might be involved. And particular interest has been paid to the nature of numerical representations. So there's been quite a lot of research that's looked into how we represent numbers and quantity information, and the role that this plays in explaining differences in mathematics achievement. And this is the case not just for preterm children, but for all children learning maths. And so one proposal that's been put forward is that perhaps preterm children have difficulties with mathematics because they have particular difficulties with representing numerical and quantity information. So one quite common proposal is that having imprecise numerical representations may contribute to mathematical difficulties. So if we're not able to represent numerical information and quantity information precisely, this might affect our ability to learn mathematics and lead to mathematical difficulties. And so it's possible that this underlies preterm children's difficulties with mathematics. The way that we look at this in research is using tasks where we ask individuals to compare different numerical quantities that might be presented as symbols or might be presented as quantity information, and ask them to select which is the larger, so they have to compare these quantities. And differences in the accuracy and the speed with which people are able to make these magnitude comparisons has been associated with different levels of achievements in mathematics. So is this a contributory factor in preterm children's mathematical difficulties? And this is something that we set out to investigate in a set of studies called the Preterm studies. And we really wanted to explore the nature of the mathematical difficulties in very preterm children. So there'd been quite a lot of evidence that mathematics was a particular area of difficulty for preterm children, but we didn't know why, and we wanted to really explore this in detail. And so this was the first study that really incorporated very detailed assessments of multiple different components of mathematics and multiple different domain-specific and domain-general skills. So the first Preterm study explored preterm children's difficulties when children were aged between 8 and 10 years old. So we had in that study 112 children who'd been born very preterm and 77 term-born peers. And the comparison group were children who'd been born full term, but were in the same classrooms as the preterm children. So we were matching them for the educational environment that they were in. And then a few years later, we were able to follow up and go back and see some of these children when they were aged between 12 and 14 years old. We weren't able to see all of the children, and we were able to recruit a new sample. So not all of the children in the second Preterm study were the same, had also taken part in the first study, but there's a subset of children who had taken part in both. And in order to try and identify why preterm children were having difficulties with mathematics, we assessed both specific components of mathematics as well as their overall mathematics achievement. And we also measured the precision of their numerical representations and some domain general cognitive skills. So just to give you a little bit of an overview, in the first Preterm study, the areas of mathematics that we assessed included overall mathematics achievement, but also specific conceptual understanding, procedural skill, and number fact knowledge within arithmetic. We measured counting skill, children's fluency at recognising digits, their ability to estimate quantities on a number line, and then finally to look at this question about the nature of underlying numerical representations. We also included a non-symbolic comparison task where children had to compare arrays of dots, and a symbolic comparison task where children were asked to compare numerical symbols. We also assessed some general cognitive skills, and this included non-verbal IQ, working memory, speed of processing, inhibition, and visuospatial skills. And what we found was that the group of children who were born very preterm showed differences to the full-term comparison group in the areas that we would expect from previous research. So they had difficulties overall with mathematics achievement, with working memory, and with visuospatial skills. When we look at the specific sort of components of mathematics, we found that it was particularly procedural skill. So this was looking at the strategies children use to solve arithmetic problems, and they tended to use less sophisticated strategies to solve problems, and they were also less accurate and slower at solving arithmetic problems than the children who were born at term. And the preterm children also had difficulties with counting skills. But most importantly, what we found was that if we took account of children's difficulties with working memory and visuospatial skills, then the differences with the procedural skills and the counting skills disappeared. So it seemed that it was the general cognitive skills that were underlying preterm children's difficulties with mathematics. And importantly, we found no differences at all between the group in the non-symbolic comparison and the symbolic comparison tests. So there was no evidence at all that preterm children had less precise numerical representations. And instead, it seemed that a lot of their difficulties with different areas of mathematics were due to differences in their general cognitive skills. And this effect has since been found in other studies with different cohorts of preterm children. So just to show you the data that we had from the measures of underlying numerical representations, we found that there was absolutely no difference in the accuracy with which children were able to compare quantities such as numerical dot arrays. They were just as accurate as the control group of full-term children. And we also found that there was no difference either in the accuracy or in the response time when children were asked to compare symbols. So there's no evidence at all that these difficulties were leading to mathematical difficulties in very preterm children. So that was the evidence that we had when children were aged 8 to 10 years old. But as I mentioned, we went back and saw many of these children again and some additional children when they had moved into secondary school and were aged between 12 and 14 years old. We gave them we assessed them with age-appropriate versions of the same measures. So we were looking at these same different components of mathematics, as well as overall mathematics achievement. But we also added in some new assessments to take account of the fact that these children were older now and had moved on to new levels of mathematics learning. And so this included children's transcoding of multi-digit numbers, written arithmetic, or so the procedural skill test had focused on mental arithmetic, and we now wanted to look also at written arithmetic. And we also had assessments of algebra and geometry knowledge. And again, we had the same set of cognitive skills that we assessed: non-verbal IQ, working memory, speed of processing, inhibition, and visuospatial skills. We found a broadly similar pattern with the older children that we had found in the earlier study. So the very preterm children had would performing less well compared to the full-term group, both in terms of their overall maths achievement, but also several areas of specific components of mathematics. So again, the procedural skill and the counting skill that we'd found in the earlier study, but there were also additional areas where children were having difficulties. And this included conceptual understanding, number fact knowledge, number line estimation, and 3 of the new assessments taking account of the more advanced level of mathematics that they were now doing. So the written arithmetic, multi-digit transcoding, and algebra. Again, we found that there were differences between the very preterm children and the full-term children in terms of working memory and visuospatial skills. And so we looked again to see how far could these general cognitive skills, could the differences in these general cognitive skills explain the differences that we found with mathematics skills. And we found again that this explains most of the differences. So only the conceptual understanding and the multi-digit transcoding did we continue to see a difference between the very preterm and the full-term group, even when we'd taken account of their cognitive skills. But again, to a large extent, the difficulties that children were having could be explained by differences in their general cognitive skills. And once again, there was no difference at all between the groups in terms of their underlying numerical representations. So there was no difference on the non-symbolic or symbolic comparison task. So these studies really show that it's not the case that preterm children have difficulties with maths because of the nature of their numerical representations. And to a greater extent, it's the case that differences and difficulties with general cognitive skills can explain preterm children's difficulties with mathematics. As I mentioned before, some of the children had taken part in both the earlier study and the later study. And so we were able to look at how the stability of the group differences over time. So these graphs show standardized scores on a mathematics achievement test for the children who were full term and preterm. And as you can see, the difference between the groups is largely stable over time. So it's not the case that the preterm children have been able to catch up with their full-term peers. However, it's also not the case that they're falling further behind. So the differences seem to be remarkably stable here. And this really suggests to us that if we want to help children who are born preterm with mathematics, we need to help early if possible, and we need to try and think about ways that we can help these children overcome their cognitive skills difficulties and learn the basic components of maths so that they can then build on this as they move from primary to secondary school. So what's the best way of going about doing this? So as I've described, it seems likely that the mathematics difficulties that preterm children have stem from differences in general cognitive skills. However, we know from a large body of research now that it's very difficult to manipulate these general cognitive skills. And cognitive skills training, such as working memory training, doesn't seem to transfer to academic achievement. So this doesn't seem like a good route to go down to try and help preterm children. So we've taken a different approach to this. And our approach has been to develop a resource for education professionals, because we think it's really important that in order for preterm children to succeed in the classroom, that those that are around them and who are supporting them have a good knowledge and understanding about the long-term consequences of preterm birth. And in particular, that it might be that we can overcome preterm children's cognitive skills difficulties by using different strategies in the classroom, different approaches to helping these children in the classroom. So what we've done is to develop an online resource which is designed for educational professionals and is completely free to use, and is designed to help teachers understand about preterm birth, understand about the consequences of it, and to give ideas about how to support preterm born children in the classroom. We developed this resource along with teachers, educational psychologists. We included parents of children who were born preterm, and also some preterm born young adults who were able to really express their experiences of going through the education system and to talk about what they wish their teachers had known and when they were at school. And since designing the resource, we've evaluated it with a group of primary school teachers in the UK. And we found that using this resource significantly improves teachers' knowledge and understanding of preterm birth. And most importantly, it improves their confidence in being able to support preterm born children in the classroom. So the resource provides information about different strategies that can support children in the classroom that is able to address their difficulties with working memory and visuospatial skills. So this can be small modifications to the way that teachers are interacting with preterm born children in the classroom, with the kinds of activities children are being asked to take part in, and the kind of resources that are available to children when they're doing mathematics or learning in other subjects at school. And I'd really encourage you, if you want to have a look at these different strategies and the things that you can do to support preterm children, to have a look at the resource, because there's a lot of information there and more than I could talk about in just half an hour. Today in this talk I focused on preterm born children's difficulties with working memory and visuospatial skills and how these relate to mathematics difficulties. But the resource also talks and provides information about preterm children's difficulties with inattention and also their broader social and emotional well-being. And there's a whole wealth of information here that goes beyond just supporting children with their mathematics learning. So just to summarise what I've talked about today, we know that children who are born preterm, and particularly those who are born very or extremely preterm, are at risk for difficulties with cognition, attention, and may have social and emotional problems. And that these difficulties can have an impact on children's learning and their attainment in school, and that mathematics particularly is an area of difficulty. And we think that teachers and educational psychologists have a really key role to play in supporting these children, both in terms of identifying the specific difficulties they have and providing appropriate support. And it seems that if we can support preterm children with their general cognitive skills, then we may be able to overcome the difficulties that they're having learning in the classroom, and particularly in mathematics. But it's really important just to remind you that prematurity is a risk factor and it's not a diagnosis in itself. So we really need an individualised approach because it's not the case that all preterm children will have these difficulties, but it's certainly worth considering prematurity if a child is having difficulties and you know that they were born preterm. So thank you. I just want to thank all of the families that have taken part in the studies that I talked about today. And the PRISM studies have a big team of researchers involved. So they're all named here on the slide, and thank you to all of them and to the funders who funded this research. Thank you.